Hello, welcome to my class. Today I'll be teaching you series connection of resistors. In talking about resistors, we said they are devices or electronic devices that restrict the flow of electric current. Now, if they are connected in series, we said this resistors possesses current that will flow through the circuit, and the current is always one, or the currents are always the same flowing through the series connection. And the connection of series will be an end-to-end power connection. It means you connect positive to negative and the negative terminal to positive. So end-to-end connection. Then the resistance in the series connection is always the sum of all the resistance components in the circuit. So this is a brief about this series connection in resistors. Now let's look at the mathematical expressions involved in this connection. Now this is our circuit. Now this is a circuit that involves resistors connected in series. So in series connection, you see that the components are connected from end to end connection. So we have our voltage here, that is the dry cell giving us a certain volt. Then current will flow through the circuit from the positive terminal, goes there, come back to the negative terminal. So in this connection, we said the current that flows in the circuit are the same in each component. And then we have our voltage that will also flow in the circuit, and the voltage here will be different. So if you want the sum of voltage in the components, then you add all of them. The voltage in R1 is named as V1. Then the voltage in R2 is also named as V2. Then the voltage in R3 is named as V3. So these are the voltages across each component in the circuit. Now to find the total resistance, just like I said, the total resistance is the sum of all the resistors in the circuit. So you add all the resistance in the circuit depending on the number of resistors in the circuit. So R1 plus R2 plus R3 will give you the total resistance. So here we add all. Now to also get the current that flows through the circuit, since the current that flows through the circuit is the same, so we can take this formula from the Ohm's law, that is I is equal to the total voltage divided by the total current. So this is also the formula to find the current in what? Series connection. Now to also find the total voltages in the components. Total voltages in the components, we can say Vt is equal to the sum of all voltages in the components. So V1 plus V2 plus V3. So this is how to find the total voltages in the components. Now you see that we have V here. Then we have current flowing through with 3 resistors. So in case you want to find the total voltage in the circuit, that is V. V is equal to the product of I with what? R. That is I times R. That's the Ohm's law. So we multiply the current and the resistance to get the total voltage in the circuit. So these are the expressions for the formulas that are involved in series connection involving what? Resistors in the circuit. Now let's go and find or solve the question that is talking about series. Now let's look at this question. The question is find the total resistance in the circuit. So to find the total resistance, we said the total resistance is always represented with RC. So the sum of all the resistors in the circuit. So total resistance will be equal to R1 plus R2 plus R3. So R1 is giving us 2, so 2 plus R2 is also giving us 3, so plus R3 is giving us 4. So the sum of all this will get 2 plus 3 is 5 plus 4 will give you 9. Now our next question is to find the total current flowing in the circuit. The total current flowing in the circuit is I, and we said it is the same throughout the circuit. So to do so, we said I is equal to the total voltage divided by total current. So total voltage divided by the total current. Where is our voltage? This is the voltage pushing the current. So we have our total voltage here. We have our total current here. So here it is 12 divided by 9. And 12 divided by 9 will give us 1.33 amps. So 1.33 amperes becomes our total current flowing through the circuit, since all the components are having the same current. Now, our next question is to find the voltages in each component in the circuit. So to find the voltage in each resistor, we say voltage in R1. The voltage in R1 becomes V1. So V1 is equal to current times R1. Current times R1. So our current was giving us 1.33 times R1 is also giving us 2. So by multiplying all this, so our answer will be 2.66 volts. So this becomes our voltage in R1. The voltage that will go in R1. Now voltage in R2 will be V2 is equal to I times R2. So here our I is 1.33 times our R2 is 3. So this one will also give us 3.99 volts. And this becomes our voltage in R2. Now let's look at the voltage in R3. The voltage in R3 will now be V3 is equal to I times R3. Our I is 1.33 multiplied by our R3 is giving us by 4. When you multiply 1.33 by 4, you will get 5.32 volts. So this becomes our voltage in R3. So that is how you can find the total current, the total voltage, and the total resistance in series connection. Thank you. If you enjoyed this video, give me a like button.